This is point A. We have a jogger. This question 2.5 in chapter 2 actually. We have a jogger that ran from point A to point B. The distance from A to B is 100 meters, and this is 30 up this way. It says neglecting the curvature. That's the first thing in the statement. So don't worry about, treat that as a line, straight line like this. What is the distance traveled and the displacement in running from point A to point B? Let's look at the distance. The distance is what? The total length traveled. Now A, that's the 100 if you go straight from here to there. But then notice if you go up and down, that's 30 meters more. Well, if you went half of that on this end, like you got to picture the person neglect the curvature as he went or she went like this. That's where you have to look at it. Because it says neglect the curvature. She went this far, then that far, then back to this point up there. Well, if you neglect the curvature, what's the distance from here to there? 15. And what's the distance from here to there? 100. And what's the distance from here to there? 15. So the distance traveled is 15 plus the 100 plus the 15, which is 130 meters. Displacement, we don't care about the path. Displacement is the difference between the final position and the initial position. How far point B from point A, the difference between them. If you measure the distance from here to there, what is that distance between them? Isn't that 100 meters? That if you do half a circle. Now, part B, what happens if you do a full circle? Full circle about the track. What is your distance traveled? You started from here, you go 15 plus what? 100, so it'll be 15 plus 100 plus from here to there, which is what? 30 plus from here to here, which is what? Another 100 plus back to this, which is what? 15. 30, 60, that's 260 meters. What is your displacement? It's where are you at the end minus where end here. Where are you at the start? The difference in the two spots. Where were you standing at the end if you did one full circle? At A. And where'd you start from? At A. So guess where your displacement is? 0. There's no change in the two position. X final minus X initial. It's the same spot. So your displacement for this should be 0 meters. Your distance should be 260 meters for that one. Let me find the other question, number 49. .49. A child slides down a hill on a toboggan with an acceleration of 2 meters per second. So there's my hill. And there's the child on a sled, toboggan, whatever it is. Here we go. He or she coming down. Acceleration is 2.0 meters per second squared. If she starts at rest, that's part A here. If she starts at rest, what does that mean, starts at rest? What's the zero? Initial velocity is 0. Yep. How far has she traveled in 1 second? What is x equal to, or delta x if you want to? T equals 1 second. This is part A. How far did she travel in 1 second? Well, when we say how far, from this spot, so really your x of 0 is 0 because that's where we're measuring everything from. Your initial spot has a mark of 0. How far from this point, so that's the 0 marker, how far did you go? Well, we have one equation that puts all these together. X equals x of 0 plus v0t plus 1/2 at squared. Some of you are asking about memorizing the equation. I said, it will make your life easier. You don't have to thumb back and forth, look for them. Boom, I can look and I go, oh no, there's this one that has all the pieces in it. X of 0 is 0. V0 is 0 times the time, which is 1, plus 1/2 the acceleration, which is 2, and the time, which is 1. Don't forget to square it. You traveled 1 meter. So in 1 second, you traveled 1 meter. And you probably want to write that because when they wrote 1.0. So try to match a significant digit, you write that 1.0 meters. That's part A. Part B is the same question except in 2 seconds. Everything the same except the time equals 2 seconds. That would be x equals, again, x of 0 plus v0t plus 1/2 at squared. 0 plus 0 plus 1/2 times 2 times 2 squared, and that will be 4.0 meters. 2 squared is 4, times 2 is 8, times 1/2, that's a 4. So that'd be 4.0. In part C, 3 seconds. X equals the same equation, 0 plus 0 times 3 seconds, up, plus 1/2 the acceleration, 2 times 3 squared. And that's really 9 meters. So notice your distance is increasing. What do I mean by increasing? If you mark in here, if this is the mountain here, you mark in from here. This is the 0 second. In 1 second here, you only traveled 1 meter. In 2 seconds, you travel how many meters? 4. That means in 2 seconds here, if you measure the distance between this and that distance should be what? 3 meters. Because it's 4 meters from here. This is 1 meter. This is 3. That's the 4 meters. In 3 seconds now, down here, You travel what? 9? You already covered 4 here. That means what? This is 5 more meters. 5, 3, and 1. That will make it 9 meters. So you can see that gap because you're moving faster and faster and faster. Every second now your distance you're covering is more and more and more. If you did 4 seconds, it will be 16. That means the next one's going to be 7 meters long, the next segment there, between second to second, if you're measuring each piece separate. So that's what's happening there. And the last question, sounds disgusting here. It says approximately 0.1% of the bacteria in adult human intestines. 0.1% of those bacteria. I don't know if that's significant, the 0.1%, or just health-wise there. These bacteria have been observed to move with the speed of up to 15 micrometers per second. They have a speed of 15 micrometers per second, which means a micro 10 to the minus 6, 15 times 10 to the negative 6 meters per second, or 1.5 times 10 to the negative 5 meters per second. I don't know if it's constant speed, initial speed, I don't know that yet. It can't be because it has an acceleration. It has an acceleration of 166 micrometer per second squared. 1 micro means 10 to the minus 6 again. And I can write that 1.66 times 10 to the negative 4. That's the acceleration. Remember, the 166 is 1.66 times 10 to the 2. That's why this becomes a negative 4. It says, assume that this bacteria in our intestine starts at rest and accelerate at this rate. This just given facts here. This is actually not what they're telling us. It says our body has some bacteria in it, our intestine. This is number what? 2.53. This actually is not even part of the problem. They're just telling us a story about it. 0.1% of these bacteria, some people notice it moves actually at a speed of 1.5 times 10 to the negative 5 meters per second, and they have acceleration up to that number. Period. That's the end of that statement. Here's the part we're interested in. It says, suppose that the E. coli bacteria that we have, that's what they're talking about. Let's assume that this E. coli bacteria that we have in our intestine starts at rest. That means has initial velocity of what? 0. Has acceleration of 156. Now 166, 156. Assume that which is 1.56 times 10 to the negative 4 meter per second squared. The question is, how much time is required for the bacteria to reach a final speed of 12 micro per second. That's 1.2 times 10 to the negative 5 meters per second. Notice it goes faster than 12. It can go up to 15. They're saying, how long would it take the bacteria to reach that with this acceleration? So that's really all we care about. The other one is just given fact about E. coli bacteria in our body. So it has nothing to do with the problem. This is the only part I'm interested in. This is part A, actually. Okay. Do we have an equation that will tie these together? Yep, first one. V equals V0 plus AT. What's V0? 0. What's the acceleration? It's 1.56 times 10 to the negative 4 times the time t, unknown, equals the final one, which is what? 1.2 times 10 to the negative 5. So to solve for t, we can say 1.2 times 10 to the negative 5 equals 1.56 times 10 to the negative 4. We divide both sides by 1.56 times 10 to the minus 4. I gotta find where the EXP or EE on this calculator. Oh, I see it. It will help if I turn the calculator on first. Negative 5 divided by 1.56, power of negative 4. Bless you. Thank you. 0.076923 seconds. Or 7.69 times 10 to the negative 2 second. Using two significant digits, 7.7. Says use two significant digits. Or 0.077. And I just plugged it in, I guess correct I get. So 0.077 or that number, that's also equals again 0.077. That's still two significant digits. Leading and lagging zeros don't count. The next question is for part B, same one. What is the distance traveled required to reach that speed? What's the distance? So part B here, come back here. Again, we know the initial velocity is equal to 0. We know the acceleration is 1.56 times 10 to the negative 4 meters per second squared. We know the final velocity is 1.2 times 10 to the negative 5 meters per second. And we're looking for x equals what? Assuming x of 0 is 0. Or we're looking for delta x basically, really. And if you think about that, that's one equation again. It's the last one. V squared equals what? V0 squared plus 2a times x minus x sub 0 times delta x, either way. 1.2 times 10 to the negative 5, square it. 0 squared, 2 times a is what? 1.56 times 10 to the negative 4 times x. On the right side, If you multiply by 2, you'll have 3.12 times 10 to the minus 4. On the left side, 1.2 to the negative 5, and you square that, you have 1.44 times 10 to the negative 10. To find x, we divide them. 1.44 10 to the negative 10 divided by 3.12 e to the power of negative 4, which is 4.62 times 10 to the power of what? 1, 2, 3, 4, 5, 6, 7, negative 7 meters. Two significant digits, 4.6 times 10 to the negative 7 meters. Don't get nervous, it's going to take a long time to move. That's how long it moves to hit that speed. Travel a little amount. So 4.6 or 0.00, 1, 2, 3, 4, 5, 6, 4, 6. Oh, I got it wrong, because it says write your answer in micrometers. Not in meters, that's in meters. In micro. I didn't see that part. So how do you convert meters to micrometers? Here we go. 4.62 times 10 to the negative 7 meters over 1 meters to micrometers. 1 micro is what? 10 to what power? Negative 6. So this will be 4.62 times 10 to the negative 7 divided by 10 to the negative 6. When you divide, you subtract the exponents. 4.62 times 10 to the negative 1, which is 0.0462. They want two significant digits. 0.046 micrometers.
That's not 0.462.
Point minus 1, right?
Yes, maybe the decimal point.
Did I move it 2 places? Yeah, I moved it 1 extra place. Yep. Thank you. Yeah, I moved it 1 extra place. Point 0.46 micrometers. And now we got it correct. I didn't see the micro till after I submit, and it says I got to do that.